Welcome to your video on adding and subtracting fractions. We're going to include both positive and negative numbers and a couple of application problems. I promise no lizards were harmed in the making of that photo. I totally can't promise that, but most lizard owners are pretty caring, so we're probably safe. Let's get started. To add or subtract fractions, each term must have a common denominator. You have a couple of different options with mixed numbers, and we'll see that within our video. And I want you to know this is an important concept we got to make sure we master soon. If a fraction is negative, only its numerator is negative. The denominator of a fraction is like the unit on a measurement. Think about 2/5 as 2 out of 5 pieces. Negative 2/5 would be like how much of the pie that you ate that you were supposed to save for your family. If you ate 2 out of 5 pieces, you made negative 2/5 pie happen. So this is more a unit than it is a number. So this isn't negative, the 2 is. The 2 is what's negative. All right, so we're going to add or subtract. Remember your rules for signed numbers because we will deal with some positives and negatives here. Okay, so for the first one we have 3/5 plus 1/3. And our common denominator here, at least common denominator here, is 15/15ths, and that's found by multiplying the 5 times the 3. Now that won't happen every single time. That will absolutely not happen every time. Rather, in this case, we multiply the two denominators because these two numbers are what we call relatively prime. And that means their only common factor is the number 1. So they're relatively prime, we're going to multiply. So remember what that means now. We're renaming the fractions. It's like making change. If you've ever needed to go somewhere and get change for a $5 bill, for example, you're making change. You have the same amount of money, it's just in more pieces. So when we find this, when we rename these fractions, we're thinking about how do we get a 15? We multiply by 3. All right. Turn the Toyota commercial down. I should really remember not to mention who it is that comes on in the commercial because then I'm kind of just giving them their free advertising. Anyway, 1/3 multiplying by 5 to get 15ths. By 5 to get 15ths. All right. And now we add them together. 9 and 5, 14. 14/15ths. That was easy. No need to simplify because 14 and 15 are, hey, relatively prime because they don't have any other common factors other than the number 1. All right, 3/8 and 3/4. Well, in this case, 8 is a multiple of 4. And so when you're looking for least common denominator, one strategy is to look at your numbers, take the larger one, and ask yourself, does the other number go into 8? Yes, it does. Well, then that's automatically your least common denominator. So I have 3/8 minus how many 8ths? Well, what do we do to 4? To get 8, we multiply it by 2. So 3 minus 6 is what we're doing here. Over 8. 3 minus 6 is -3. So we have -3/8. And this is what we were talking about before. The negative sign can go up top, or the negative sign can go in line with the fraction bar, but I don't want to see the negative sign in the denominator. Please. Because we're not talking about 8s being negative. It's the top part that's negative. It's -3 pieces out of -3 pieces out of 8 total pieces of a whole thing. All right, next one, we've got -1/6 and positive 3/4, so plus -1/6 plus 3/4. The least common denominator here, use your method of taking the larger number and asking yourself, does 4 go into 6? No, it does not. Now take multiples of 6. The next multiple of 6 after 6 is 12. And that's our common denominator because 4 does go into 12. Oh, and I already messed up, didn't I? Anybody notice that? That was close. Remember, if I mess up, make a note of it, be polite about it, come and tell me about it on Edmodo or by email, and I will edit it and give you credit. Okay, so now we multiply both by 3. All right, so why did I multiply these by 2? Well, 6 times 2 will give me the 12. So 1 times 2 gives me the same amount of a fraction as 1/6. 2 pieces out of 12, same as 1 out of 6, and we got 9 out of 12. So now I got to think about this here. This is now -2 plus 9 over 12. -2 plus 9 is 7. 7/12. Let's do a few more. 1/8 and -5/6. 1/8, and negative 5 6. So again, we need a least common denominator. Least common denominator here. And I'm also going to think about what I've got here. I'm adding a much larger negative. So this is positive, and this is a negative, and it has a bigger magnitude. It has a bigger absolute value, which we talked about in class. So what's my least common denominator? Well, 6 doesn't go into 8, but it doesn't go into 16. Nope. 3/8 would be 24. Oh, 6 does go into 24. So multiples of the larger denominator. What do I multiply it by to get there? 3. Plus, what do I multiply it by to get there? 4. Negative 20. So I have basically 3 minus 20. Well, 3 minus 20, or 3 plus negative 20, is going to be negative 17. So negative 17 24ths. I should look back and make sure that makes sense. I am adding a much bigger negative. Oh, I forgot to write in my least common denominator here. I am adding a number that is much more negative than the positive, has a larger magnitude, has a larger size than this positive. So it makes sense it would come out negative. How about here? We have a subtraction problem. These always give us trouble. Let's remember that we can use keep, switch, switch, just like that. So they're both now negative. So basically I'm adding negative 3/10 and negative 5 3/4. My least common denominator this time, what's that going to be? Oh, please excuse my phone. That's an Edmodo notification. Least common denominator here, 4 does not go into 10. How about 20? Does 4 go into 20? Yes, it does. 20 is our least common denominator. All right, so we multiply by 2 on the top and the bottom. So negative 6 20ths plus negative 5 and how many 20ths? Well, we've got 4 times 5 to get to 20, 3 times 5, so that's going to be 15 up top there. So now I have 2 negatives, and I'm adding 2 negatives. We learned that that's same sign, add, and keep. So I have no whole number over here, no whole number here in front of the 6 20ths, but I have this 5 over here. So I'm going to go ahead and put down my negative 5, because I'm not adding to that. Not yet, at least. Negative 6 and negative 15. So negative 6 plus negative 15 20ths. So this has the equal value, and this is how I'm thinking it out. So negative 5 and negative 21 20ths. Well, that's improper. So one of those has to go on to my negative number, my negative whole number, excuse me, my whole number. And I have 1 20th left over. Now, this can get confusing right here because we ask, well, which is negative? Is it the negative 5? Or coming all the way back here, is it the negative 5 or is it the 3/4? It's both. It's negative 5 and 3/4. Think about it in decimal form, negative 5.75. Like negative $5.75. The 75 cents isn't positive. It's still like if it's like you owed it to the store, it's still a negative. So try to think about adding 2 negatives. It's really the same exact thing as adding positives. I'm just keeping the negative signs on there because I know they're actually negative. Still just like a positive situation, both parts being positive, and then put it back together. All right, this is the last one of these we're going to do, and we'll look at a couple of application problems. So here's the issue with this one. Let's go ahead and rename with the common denominator. I'm going to speed this up. I want you to do the same thing. Pause it and do it. I'm going to go ahead and pause it in just a second and give you that common denominator. So you pause it and do the math. All right, here comes your answer. I didn't really mean answer. Here comes your renaming is what I really meant to say. I'm sorry. Okay, so here we have 9 minus 7, so that would be 2, but 9 minus 10. We are subtracting more than we have. Well, there are 2 ways I like to think this out. Okay, there are 2 ways I like to think this out. I do not like to borrow, but I will do it once in a while. So let's do the borrowing method first. Let me see. Can I zoom into my situation here? Whoa, I can. I didn't know I could zoom in. All right, so let's borrow first. Okay, so if we're borrowing, that 9 and 9/15 is not going to be 9 anymore. It's going to become 8. And we're taking one whole thing off of that whole number, and we're putting the 15ths over here on the fraction. So now that gives me 8 and 24/15, subtracting 7 and 10/15. So that is one way to do this. We get 1 and 14/15, and we're all set. But this bothers a lot of kids. They get really lost right here. So let me show you the other way we can do this, or another way we can do this. And there's actually even going to be a third way. we can do the, let's call it the part positive, part negative solution. Instead of doing 9 and 9/15 and renaming, let's actually do the subtraction. Well, 9 minus 7 is 2. 9 minus 10 is -1. So now this number is part positive and part negative. If I now take this whole 2 and take off 1/15 from it, I'm left with 1 14/15. Ha! Look at that. All right. There is even a third method. I'm going to use my space up here because I'm out otherwise, and that would be to make them all improper fractions. Now, this would have been much more convenient before I renamed the fractions, but we'll do it anyway. So that would be multiplying 15 times 9. 15 nines, let's see, 90, and 45 is 135. 135 plus 9 is 144. So I made it an improper fraction. Okay, now we got to do 15 times 7. 15 times 7, so 70 and 35. 70 and 35 is 105, plus 10 is 115. Oops, switched to pen. All right, and then subtract 144 minus 15. 144 minus 115. Let's see, 14 minus 5 is 9. It's now 13. Oop, sorry, accidentally hit pause. 13 minus 11, so 29/15, which is, again, 1 14/15. So there's 3 different methods, 3 different ways. Take a second and jot in the margin of your notes, please, which one you actually preferred. And you don't get to answer none of them. I know fractions are painful. I get it. But you still have to answer the question. One of those 3 you liked best, and I'm going to ask you about it in class. All right, let's look at some application problems. Okay, let's take a look at this application problem. To set up a computer network in an office, a 100-foot cable is cut and used to connect 3 computers to the server as shown. How much cable is left to connect the 3rd computer? You got 19 1/8, 40 3/4 feet, and then we don't know this one. That's what they want to know. So we understand that we've got a 100-foot cable, and we're using it to connect the computer servers. These are some of the things you might actually write down in your notes. So you might actually write down that there's 100 feet of cable total. 100 feet of cable, and you might write down these 2 numbers. And we know that we're going to add those measures that were already used and then subtract that sum from 100. That's a good plan. That's a good simple plan. You can see the math done for you, so let's go over it real quick. Common denominator of 8 found, added together 59 7/8. When we subtract, they chose to use the borrowing method. So they took the 100 and made it 99 8/8, as you can see right over here. So if that's the method you would have chosen, great. If not, what would your method look like for that problem? And in the end, we ended up with 40 1/8 feet of cable left to connect the 3rd computer. And while I didn't go over it, always a good idea to estimate in your mind. And you can see that's what was done over here. And yeah, it was darn close to the estimate. All right, a couple more quick problems and we're through. Okay, let's take a look at these 2 quick problems here. First one's a thinking problem, second one is a challenge that I'm going to leave you with and you can try out and bring with your notes to class tomorrow. Cooper and you are adding the fractions 1/3, 7/9, and 4/15. Their first step is to find the least common denominator of 3, 9, and 15. Is either of them correct? Explain your reasoning. Cooper, the least common denominator of 3, 9, and 15 is 3 because 3 divides into all of these numbers evenly. And you says the least common denominator of 5, 9, and 13 is 90. Is 90 because you can divide 90 by all 3 of those numbers without getting a remainder. Well, it's true for the correct number too. I think that's just a typo. This came from your textbook. Go textbook. I think it's supposed to be 3, 9, and 15 because that's what we have in the problem. I think they just typed that wrong. Well, technically, neither of them would be right. Sorry, I meant to write. Technically, neither would be correct, but if we use work there, then he would be the right one. What did Cooper find? He didn't find the least common multiple. He found the greatest common factor. That's what he found. Last problem, and I'm going to call it quits with this video because it's right about 15 minutes. A set of measuring cups has measures 1 cup, 3/4, 1/2 cup, 1/3 cup, and 1/4 cup. How could you measure 1/6 of a cup of milk by using these measuring cups? Let's see how many different cool answers you guys can come up with before class tomorrow. See you in class.